welcome to Chapter 12 and 13. Today's video will introduce us to the different types of mixtures and some of their properties. The three types of mixtures we are going to look at in tonight's video are solutions, suspensions, and colloids. So let's begin with solutions. Solutions are a homogeneous mixture of two or more substances in a single phase. So homogeneous, what does that mean? It is the same composition and properties throughout. So if you look at our two examples, the first one is homogeneous. It's the same throughout. If I took a square, or a rectangle, I guess, in this area, and I took the same area in my other mixture and compared them. In my homogeneous mixture, I would see that I have 3 blue and 3 purple. And if I took another square that's the same size, even if it's in a different orientation, I still see that I would have 3 blue and 3 purple. However, in my heterogeneous mixture, this is not going to be the same throughout. So in this case, I would have 1, 2, 3, 4, 5 green and 1 yellow. But could I take then the same mixture over here like I did in my last one? Sorry, my squares aren't as nice. But in this case, I'd have 1, 2, 3, 4 yellow and 2 green. So my samples, although both of them the same size, they are not the same. Whereas in my homogeneous mixture, both my samples are going to be the same throughout. The ratio of one color to the other is always the same. So solutions are made of solute and solvent. The solute is the substance that is being dissolved, and it is usually in lesser quantities. So in our picture here, this is our solute. It is going to be put into our water here, which is then considered our solvent, or the dissolving medium. The water is going to dissolve the salt or sugar, whatever that picture so happens to be. And the solvent is usually in greater quantity. So if you were given numbers to really determine which one is the solute and solvent, the solvent is usually the greater one. So in this case, our water would be our solvent. Solutions can exist in any state, and it can be any mixture of one thing kind of dissolved in another. As long as they are dissolved, and you have a nice homogeneous mixture. A typical type of solid solution is called an alloy. And we often use alloys when we're making things because they have a higher strength and greater resistance to corrosion. Common examples would be brass, sterling silver, which is a lot of that silver jewelry that you will wear, and 14 karat gold. That's why 24 karat gold, which is almost pure gold, is going to be so much more expensive but a lot more brittle. So usually you go down in carats in gold because then it has more of the silver and the copper, which actually will make it stronger. The second type then of mixture is a suspension. In a suspension, you have a mixture in which the solute particles are too large that they settle out of the solution unless we constantly stir them. So in this case, you can think of having a stirring rod or your spoon in there, and you stirred up this solution so all of the particles are suspended within the liquid. And as long as you constantly stir that, you're going to get that suspension. But you remove that, and now your stirring rod is out of the solution. You're going to see that the black or the brown gunk then settles to the bottom. So this would be our solute that has settled out of our water here. So as long as we stir it, we're going to get a nice solution. We stop and we get that settling out. So this solution would be, or this suspension is considered heterogeneous. Again, that's that difference. If I took a sample here and I took a sample here, they're going to be completely different. Even in this, if I took a sample near the top and I took a sample near the bottom, depending on how well I stirred and the size of the particles and how heavy they are, you could also get different samples. So then our go-between are going to be the colloids. Colloids have solute particle sizes that are between those of solution, so a little bit bigger than the solution, but not as big as a suspension. We still cannot filter out the particles of a colloid. So even though they're getting bigger, they're still, if you try to pass it through the filter paper, your filtrate's going to look exactly the same as what you started with. You wouldn't have anything left on the filter paper. And the big thing about a colloid is it undergoes this Tyndall effect. So the Tyndall effect is the scattering of light by colloidal particles in a transparent solvent. So if we didn't have light on it, it's going to look like this. So you don't shine the light on, we get something that's transparent. You're not going to necessarily see all the different parts. However, you shine a light on it and the light's going to start bouncing around off of those particles. So those particles are bigger in size even though you can't see them. So then you would get this beam of light that you see going through here. Plus you can see that you still have the shade, you can't see the beam, but it lights up all of it. This, in this case, if you compare the two now, this would be a true solution because that light, you can't see that beam going through. There's no beam shown. So this would be a solution where this is your colloid. Because again, you can see the beam, you can't see the beam. But take off the beam and they would look exactly the same. Just like in our picture here with the car. We've got the car and the light beams. Just like when it's foggy outside and you can actually see your beam of light, where on a clear night you can't see those beams. When you have the fog, your light is shining off the different particles that are in the fog. So let's pull it all together and kind of list these so we can compare them side by side. So we've got our three types of solutions, or three types of mixtures. We have solutions, colloids, and suspensions. Let's classify them by how they kind of separate out. Solutions are homogeneous mixtures. Colloids are considered heterogeneous. Because you could get areas or pockets that are a little bit different. And then suspensions, of course, are heterogeneous. In solutions, you actually dissolve your solute into it. It's broken down now so that you cannot see the actual particles. In a colloid, when you dissolve those solute particles, they're not considered dissolved, they're considered dispersed. So we have actually moved them throughout. They don't actually dissolve. So you may actually be able to see them, especially when they get on the larger end. And then in suspensions, they're considered suspended. So as long as you are stirring, those particles, those solute particles that are in the solvent are considered suspended, but you can see them. Solutions will not separate out, so as long as you have it sitting there, you're not going to get the solute settling to the bottom of the solvent. Same thing with the colloids. As long as they're sitting there, they're going to stay in that dispersed state. Suspensions, however, the particles are heavy enough that they will eventually settle out unless we keep stirring them. In solutions, you have really small particle size. Colloids, you can see we're now getting much bigger. We've got a bigger range there. And then suspensions are your largest particle size. Solutions cannot be filtered. So if you made some salt water and you tried to filter the salt out, we couldn't just pass it through a filter paper. Same thing with colloids. It wouldn't go through, or it would go directly through that filter paper. It would not stay on the filter paper. And suspensions, you can filter them. So you could actually take your sand and water, pour it through, the water goes through the filter paper, the sand is going to stay in the filter paper. And then solutions, you can't see the particles, but they are not going to scatter light. Where colloids, you may also not be able to see them, but they will scatter light, which we described as the Tyndall effect. And then in suspensions, they may actually scatter light, so you'll think, oh yeah, it's doing this Tyndall effect, but it really isn't. And that's just because the particles are so large that light could bounce off of them. But it does not, or it is not considered the Tyndall effect because, again, if you stop stirring a suspension, it falls to the bottom, and then that solute on top may not have the Tyndall effect, or the stuff that has settled to the bottom, it may not actually let light pass through it.